and welcome back, everyone, to the ResearchVR podcast, the podcast behind the science and design of virtual reality. Today, we're joined by a special guest, Jesslyn Tannady, the technical product manager at CTRL-labs. Hello, Jesslyn.
Hey, how's it going?
Great to have you here and excited to have this conversation. And of course, we have beaming in from Germany, Mr. Peter Leckhoff.
Well, hello, everyone. I'm also very excited about the topic today. It's totally future-proof, mind-blowing.
Super futuristic, in fact, with lots of news going on about brain control interfaces and Neuralink. I thought it was going to be a perfect time to talk to one of the people or one of the companies that is really leading, is a leading product in this space. So today we're going to be, I guess, talking about like brain control interfaces, just the topic of like new input mechanisms in general, about human computer interface, talking about EMGs, and also I guess kind of an update on the what was it called? The thalamic,
the Myo band, famous Myo band.
The evolution of where that product went and how it's been integrated into this company. So, Jesslyn, hello. I guess let's start a little bit with you and kind of your background, how you found yourself working and doing research in like VR, AR space, and yeah.
Sure. So I would kind of cite the beginning of my VR journey at Global Game Jam in, I want to say 2016, probably. At the time, I was really into the concept of developer communities. Developer communities were always a really big part of why I got into tech and why I stayed in tech. So I signed up for this event, Global Game Jam. I thought it was a hackathon focused on games. Attended, met a bunch of really awesome people at the event. And they kind of introduced me to this amazing world of game dev, kind of like bring my two interests together, technology and coding with graphics and design. So kind of got into that. And I mean, 2016 is kind of the year a lot of people cite as like the beginning of this wave of VR. So there was a lot of really interesting things going on. And one thing that really interested me about the VR space was the fact that there were a lot of people from so many different disciplines in this space. So I was talking to programmers, I was talking to reporters, I was talking to writers, authors, people who worked at museums, all people who were very interested in the space. And I thought it was just such a great community and such a great place to be. So delved a little bit more into that, and I ended up interning really briefly at this VR startup in Korea called Reality Reflection, and they built this game called Music Inside, which was one of the first games that was released when the Oculus Rift came out, I believe, in 2016. So that was a really fun place to be, and ended up going back to school after that internship. I did a kind of like research assistant program really briefly at the MIT Media Lab working on VR stuff. And then I stumbled upon an opportunity in MIT's Astro department. The gist of it was that, it's like navigation in space. We haven't really, there's a lot of like cool work going on there, but what if we could use AR and use augmented realities to make navigation on extravehicular activity missions, kind of like on the surface of other planets, more intuitive, more accessible, kind of reduce the mental burden of what it takes to navigate, so that astronauts / like other scientists in space are able to do more productive things with their mental bandwidth. So I did that for about a year and a half, working with HoloLens at the time. And I think a big thing that kind of was on my mind 24/7 was how can we make this more intuitive? How can we have like a more intuitive interface between humans and computers and our machines and systems? And that's kind of what brought me to CTRL-labs. They were, at the time I first heard about them, they were working on this device. And I remember the very, very first time I heard about them, I thought the company was fake.
Why so?
They told me that they were doing there was machine learning, there was VR, there was neuroscience. It sounded like a fake company full of like buzzwords. And like I hopped on a call with them and I was just like, okay, what are you guys really doing? And I found out this was real and I was like, wow, this is so cool. This is going to change everything. And I'm like interviewed, ended up here, and just really, really excited to be able to work on this problem.
That's awesome. I guess how do you know kind of the background behind the company, how where people came together from, and why they wanted to form CTRL-labs?
Yeah. So this company started about 3 years ago, and it was founded by this guy called Thomas Rudin. He was the original author of Internet Explorer way back when in the day. After his whole tech thing, he went back to grad school. I think he studied classics and neuroscience. So just stuff that's very different from his life in tech. And I think something that he was inspired with was the concept of, it's how we can better interface with our machines. And this problem was so compelling to him that he decided to return back into the tech space and decided to start this company. And pulled together a bunch of people from his Columbia PhD neuroscience program. So our chief science officer is this guy called Patrick Kaifosh, who is really brilliant guy leading our science team. He also pulled a bunch of his ex-Microsoft friends. So our chief operating officer is also an ex-Microsoft person. And from then, and our chief strategy officer, Joshua Duyan, worked at Luminosity, which was a startup that worked on consumer products for using neural interfaces. Right. So he pulled a bunch of these people, and slowly the team grew and grew. We ended up hiring some top neuroscientists around the world. A bunch of, honestly, I think a lot of large tech companies are represented here as well. A lot of awesome people from a lot of different diverse backgrounds working here. Yeah.
Seems like there's the whole, sorry, Peter, but it seems like the whole roster is just full of neuroscience PhDs. So I guess if you bring brilliant people together, there's got to be some interesting things that come out of that. So that was, I guess, 3 years ago. And for the last 3 years, what has been being worked on is CTRL-kit.
Uh-huh.
And CTRL-kit, as far as I can tell, is kind of composed. Actually, why don't you kind of introduce kind of what CTRL-kit is and what it's supposed to be?
Sure thing. So, like I said, the original problem that we wanted to focus on was how can we better interface? How can we close the delta between humans and their computers? How can we create the ultimate brain-computer interface? And what we created was an armband wearable called CTRL-kit. So it kind of sits on your arm a little bit like a Apple Watch, I guess. And the reason we chose the arm is because we feel or the hand, the space around the hand, is because we feel like the hand is the most densely innovative part of our body. And there's just so many signals that go through our arm and to control our hand every single second. So, it's an armband wearable, and it, has a bunch of electrodes that sit on the surface of your skin. And every time you move your muscles in your hand, your brain, or I guess neurons get fired, and we detect those neurons, and it's just a lot of noise, I guess, and we use machine learning algorithms to get signal from that noise.
One very important question. So you really put the emphasis on measuring the neuronal activity, right? It's not so much about the muscle activity, but you rather filter out the muscle activity and get probably the neurons going from your muscle to the hand, right? So the axons, or how would it work?
As I understand it, neuron fires control our muscles and how we move. So I wish I could default to one of our scientists, but I don't have a neuroscience PhD, unfortunately.
Of course.
As I understand it, the two kind of go hand in hand.
But the idea is to kind of pick up on the intent that you want to move certain fingers, but without actually having to move it, is if I'm understanding correctly.
Yeah, so that's one such application of it. And I feel like that was one really compelling thing for me. Because imagine you have your hand in a fist, but you are intending to open your fingers, kind of splay your fingers. You're able to kind of push those, trigger those neurons / prompt those muscles to do that without actually opening your hand. So think of just the concept of tension in your muscles. And I think that's really, really cool because you're able to communicate things without actually doing things with your, I guess, physical hand. So these are the kind of signals that, say, computer vision based solutions wouldn't be able to pick up on. So I feel like that's a really interesting problem space.
Right. But I guess that's not the only way that you want people to use it, but it's also to actually move your hand or muscles and your fingers, and to kind of do almost motion tracking in that sense, but from a neural perspective, from the actual, is it neurons in your arm?
No. So I'm actually checking Wikipedia on the side because I managed to forget it from my studies. It's probably the motor neurons that are located also across the body, and they have those very long fibers. You can call them axons, but you can also call them efferent nerve fibers, and they basically go from either your the part of your stem or actually also the spine towards the muscles, and they're very long, and probably this is a signals that they can pick up through the noise, from what I understand.
So, the connection between like your motor cortex to your actual fingers. There's a lot of activity and a lot of electrical activity that's being transmitted through there, and you're picking up on those using EMG, I think, EMG device. Okay.
That's right.
Nice. So I guess what other hardware kind of goes into CTRL-kit? Like how does it work? How is it built?
Let's see. Hardware. We have the actual device, which sits on your arm, and we also have kind of like a receiver at the moment, which it's like very small, it's very portable. You can kind of take it along, and you're able to just plug into your computer, and it receives like the signals from the device.
Got it. Okay. And then I'm guessing that's like some sort of Bluetooth or maybe some Wi-Fi.
Bluetooth, yeah.
Yeah. Okay, cool. So this is something you want to use with your PC. So I guess maybe we can also talk about kind of like what you've already shown. I mean, there's a few public videos on YouTube that have been posted kind of to show like one of the ones I saw is like hand tracking and finger pointing tracking. You've also used it as kind of a video game control interface. So what has been the most interesting things that you've kind of seen or worked on yourself? What's worth talking about?
Yeah, I think I'm going to talk about the three things that I think the three coolest things I've seen with CTRL-kit that are real, that are available. So first is an application that an application that was built in-house using robotics that we got from external people. But basically the idea of it was being able to, it's like the idea of it was, what if we could control things in the real physical world using our intentions, right? So what we got a robot with a bunch of different joints. So think of like an arm, but with like more joints than our arm has. And we were able to control that with CTRL-kit. So someone within the company, one of my coworkers, was able to, pick things up with it. I think he scratched his back with it, and he was able to control this like robotic arm that has more limbs. So it's like, because it has more limbs than his arm, it wasn't even a 1-to-1 mapping. So he was able to kind of like control this robot in a way that was intuitive to him. And I thought it was really cool, just like all the potential applications of this, being able to, just like this robot being able to pick things up for people, being able to do tasks for people. And in that time, all you have to do is kind of intend it,
Yeah, that's really interesting.
So that was really, really cool to me.
So it wasn't even using it didn't even require the actual movement of the hand or the fingers to control the robot, but it was more intent based to move it in certain like axes, each joint. Okay.
Yeah, basically. So I guess like thinking in the future, some potential applications there, obviously like robots that do things for you. I'm thinking also of robots that work with that have to like maneuver things in 3D space. Right. At the moment, as I understand it, a lot of the controls for it aren't as intuitive. You get a bunch of like levers, a bunch of buttons. But what if you're able to control those robots in an intuitive way? And I think just kind of thinking of the research I did in my past life with space, I think it would be really cool to have robots out there in space such that you're able to control things without having to ingress into spacesuits and do that, all of that. Just like be able to control things out there in an intuitive way. So robotics. Another really cool application that I've seen is typing. So I think a huge problem I have right now with the current state of, XR/spatial computing is that we don't really have good text input. So, there's that kind of like laser pointer thing where you, like point and click. There's that HoloLens thing where you have to kind of look at it and then tap, and that's really slow. It's not very high bandwidth. The other thing I've seen, I think, is the Magic Leap mobile app where you can kind of type on your phone and send it. But even that is, you have to have this whole other device. You have to kind of look down and it breaks that immersion. So something that we've created internally is the idea of an invisible keyboard. And again, this is kind of like a proof of concept, and we would love to expand on this. But what if you were able to have a keyboard that follows you everywhere and is able to, well, learn you, I guess, learn your neuron pattern fires, learn the way you type and the way you want to do text input. And I thought that was really compelling because you don't really need this whole keyboard. You don't need this device out there with you. You're able to do it everywhere, anywhere, like tap on any surface, right? And on top of that, I can imagine a world where we kind of like do gestures in air such that like, you're in VR, you don't have to like go find a table, feel for a table. You're able to do this by yourself. And I think that's really cool because I'm just thinking of other input controls or like input methods in the XR space right now. You get a lot of like rod shaped controllers, right? But you have to kind of contort your hand in a certain way, and it's like it's not great for typing. And then separately, even computer vision based stuff, it's like it's hard to type with that. So I thought that was insanely cool.
Typing is a very open question still with VR and AR, and that's a topic we've talked about pretty commonly actually on this podcast, and whether it's like using the drum keyboard where there's like a stick coming out of your controller and you're typing on a huge keyboard with like drumsticks, and I that's actually one of my favorite ones that normal VR made. There's I guess like there's simple Steam VR kind of like raycasting onto a keyboard. There's stuff that we'll be able to do with eye tracking soon enough. I know that's been something that has been in research. But okay, so this is interesting. I think maybe we should dive into this.
Before we end typing, maybe one short question. So how long do you need to train the algorithm to detect what you kind of type? Because it sounds really amazing. And honestly, if you can build that, I think you would literally disrupt the whole XR industry. Because frankly, I agree with Azad. If you can figure out a really good way for typing, and research has been done, to make it happen, we could make way more things. But how persistent is this signal in the neuronal signals, or how much do you need to pre-train? Do you need to sit for 20 days and type a lot on the same buttons so it kind of knows it, or is it kind of more universal and scalable?
Yeah, so I think before I answer that question, I'd like to talk a little bit about the history of like how things have been developed at this company. Sure. So we develop like interfaces, and we used to have a world where people would have to train for hours and hours, and then eventually it gets better at understanding what's going on and what you're doing. And now with CTRL-kit, you're able to just put things on. And it kind of knows your gestures, it knows your pinches, even though you are not specifically, even though you are not in the data set, it's able to work out what the way other people like do a fist, or the way other people pinch their fingers, and kind of work out what you're doing there. And today, CTRL-kit, I'm able to do it cross session, so I can put the device on, take it off, put it back on. And it's kind of like rotation invariant, like it knows. Similarly, I'm able to kind of like give this device to my coworkers, and they're able to put it on, and it works it out there. So for this typing thing at the moment, I'm like, it's a very like new and exciting project, and we feel like it would have a lot of amazing repercussions. Today, we're still near the beginning where it would take some time to train, but we're slowly moving to a world working to move towards a world where this would work very quickly.
I mean, is it that fine-grained detailed where you can really detect, like, because if we're talking about typing, like there's a matter of like centimeters or a few centimeters apart for each key. Like, is that the sort of resolution that you can detect with when it comes to like pointing or clicking or tapping on surfaces?
Yeah. So we have a video that's out there on YouTube that shows someone typing, but it's a very old video and it's completely outdated. Even the device is generations behind. What we have today is is kind of like the means to essentially type exactly as if you were using a keyboard. And that is kind of like proof of concept to show that this works. I think the next step is kind of working out more intuitive input schemes, control schemes for text input. But to answer your question, yeah, we had two people chat over like a chat bot, and they were able to type and communicate in an intuitive way.
Wow. Okay. That's pretty, I don't want to oversell this because I think it sounds like it's definitely, it's a work in progress and it's an early kind of prototype. Like, hey, this is the resolution of what we can bring to the table. And one of the applications could be typing, which I think is really interesting. And of course it comes with like, even though let's say it works perfectly for everyone, there's always the question of like, do you want to be tapping your fingers on either in air or on the ground, or does it make sense to just use your iPhone or your smartphone for that? Like these are open questions, and I think if we want to talk about it, we can. But that's really interesting that that's one of the use cases that already works for you.
Yeah.
How much variability is there between people? I guess this is something I don't really know very much about, but yeah, I guess, and I'm sure it goes into like how you guys do your machine learning, like, or you're just trying to create, what a typical user is. But like, is there a huge variability in the types of signals and the location of the signals between people?
Yeah, so as it turns out, there's a lot of variance in the human population, and biology is complicated. Sure. I think what's really cool about this is that there are a lot of differences that you cannot really tell just by looking at someone's arm. Apparently, some percent of the population has or does not have like a certain tendon. That, or I forget, someone explained this to me, but
you're right. Yes.
Yeah, so just like these things that like are just like a lot of, there's a lot of variance there. So we do a lot of, we collect data from consenting users, obviously. And we, like you said, we kind of feed things into a data set and train machine learning algorithms on it. Slowly it gets better. And it works out what people are able to do, even if they're not in a data set.
Nice. So, I by the way, the tendon, the reason why that like struck a thing, I just recently watched a video about this, about how like we have like certain things that we've evolved out of being necessary. So one of them is this like something called the palmaris longus muscle, and it's this like vestigial tendon that's in your wrist. And for some people, when you clench your fist, you can kind of, or your fingers, you can see this tendon popping up, and for some people, it's not.
Yes, that's the one. Yeah.
So I guess you have to factor that in if you're building this.
Yeah. But I think on top of that, it's just like different ways like your muscle kind of like curves around your arm, I guess. There's a lot of variance there, muscle thickness, things like, I don't know, body fat, how muscular people are. There's like a lot of variance there.
And probably go over patterns, right? So it's not even that much the activity of each muscle itself, but rather it's similar patterns that the device can pick up no matter where it sits.
Yeah, that's how I understand it. Yeah, there's just like, I think our device just picks up so much signal. And this is more of a problem, like working out how to interpret the signals.
Right. What's the state? So this is clearly a developer kit, right? And you want people to be using it. Is it available yet for developers, or what's the state?
Yeah, it's available for developers, and we've given it to a bunch of people outside of the company. At the moment, we're slowly rolling out, but you can sign up for that on our waitlist on our website at control-labs.com.
Cool. And so I guess I'm guessing that's kind of like an early access first. You've given it to your first early partners, and then I'm sure there's like a broader list of people that could come. Like, what's the sort of, do you know any sort of timeline? So if, like a lot of our listeners are like VR developers or AR developers, and I'm sure they would be interested in something like this, but is there some sort of a timeline for that, or?
Yeah. So at the moment, we are, I guess like my goal personally is to get this in the hands of XR developers, kind of bring it back to my people. At the moment we are, it's a developer kit. We're creating devices. We're constrained a little bit on, the rate at which we can mass produce these devices. But my goal is to get it out to as many people as possible and see what kind of cool things people build with it.
What would be the perfect application?
Sorry?
What would be like the perfect application, or like the perfect case where I would say we definitely will produce even more? So what kind of things are you searching for that developers do?
I think one thing that I think about a lot when I think about what the perfect application is that we are a company at CTRL-labs, we're a company of about 70 people and 25 plus PhDs, I think. We're just 70 people, and we come in with a certain set of experiences and a certain set of things that we're excited about building. I think the real cool thing would be if we give this out to people, give it out to the world, and see the kind of things that people build that I couldn't have possibly imagined.
I love these super diplomatic answers.
No, seriously. I guess like
go into politics.
The big analog I think of is like YouTube. Like things got really interesting once they like gave it out there to the world, and literally anyone can upload a video on YouTube, and there's just like all this crazy stuff out there that I imagine the people who created YouTube wouldn't have been able to think of. So and we have like all these like memes and things that come out of YouTube, and it's just like our CEO likes to another example or comparison that our CEO likes to bring up is it's like asking the person who like I guess like came up with electricity, but it's just like kind of got that in the hands of like people. It's kind of like asking that guy, it's like, what do you hope people do with electricity? It's like, how could they have possibly imagined the internet? There's just like so much out there.
So it's funny you mentioned memes as like the thing that comes out of when you release something to the public. Yesterday I was it's almost hard to talk about it because it's so funny. But like yesterday, my friend was telling me about the Photoshop content aware stretch, and which was something like developed like in the mid 2000s, and it was supposed to be a way of like cropping or stretching an image without it actually cropping. Like it moves the things in the foreground, but then the background gets cut. That's what it was meant for. But actually, the main use for it now is to make like these hilarious like stretchy face memes that are like horrible looking, but it's just like you do it enough times that it turns into a horrible face, and it's like that's the main use case for it. So
I feel like that's a perfect example. It's like the person who came up with that, or the people who came up with that, probably wouldn't have imagined it for that use case, but here we are, and it's funny.
Exactly. Okay, so that's understandable. So it's early stage. Some developers are using it. I guess is there any public information in terms of like what companies have kind of used this already, or like have even experimented with it, or like used it in their production? And I guess what are the best case scenario in terms of is this geared more towards B2B use cases as a developer kit even for now, and what kind of comes after like in the product line?
Yeah, so I think our vision for the company is to be able to bridge the gap between humans and computers, right? So adoption is a huge priority for us. We want to make that as frictionless as possible. So the plan is to give this to as many people as possible with as little friction as possible. And I think kind of down the line, working out how to kind of like providing, I think that our real product here is like the machine learning models that we provide to people. So in terms of like getting the device in the hands of people, we'd like to make that as frictionless as possible.
Sure.
But maybe a short question. So from what I remember, Leap Motion also basically developed software technology behind it. That's what they put the emphasis at some point on. So could you argue that one of your goals could be to just be inbuilt in many other devices? You just basically provide the IP of this model. Is it something that you're looking for, or do you think that it has to come holistically out of your company? Otherwise, you don't have enough control of hardware, software, or whatever.
Yeah, I think back to the original goal, get this in the hands of people and change the way we interact with computers. So if that is, if a company decides that like, it's like, hey, we have this really compelling idea on how we can, it's like use this device for XR purposes. I feel like that's something that we would be really excited about.
Right.
Nice.
So I'm guessing it's like B2B companies then. That's kind of the original set of developers that would make best use of a technology like this.
We have given the device to independent developers, XR developers. So those are people who I would consider, it's hard to say consumers because I don't really think of this as a consumer product. Sure. I guess our business to those developers. So it's not just big corporations or enterprise.
Yeah, no, that's kind of like what I was getting at.
Oh, I see.
Because a lot of times you see on Reddit and like our Oculus, anytime there's any interesting new, like, especially when it's like haptic gloves or, I mean, when we had the Haptex glove people on, like, anytime people see it on Reddit, they just comment like, oh, I wish I could, have it, but here we are. It costs like, lots of money, and we cannot, it's not supposed to be for consumers yet. Like, this is the way things happen on the really cutting edge hardware. It's bigger companies that are willing to pay for it because they have clients and customers that would use it for very specific things. Yeah, I guess that's, I mean, let's talk a little bit more into the future. Like where do you see CTRL-labs being, let's say in like 5 years? Is there a more like how does this product kind of evolve? Do you add more sensors to your hand, or is there something that also you can gain more information by also like tapping into your cranium, like without like, non-invasively? Because I think that's clearly that's like the main thing that you guys are going for with the armband is a non-invasive types of sensors. But yeah, like how does this grow?
Yeah, I mean, there's just so much in the future that we could possibly do. For me personally, I'm really, like I said before, I'm really excited about developer communities. I think my ideal, like where we are 5 years from now, is that this is something that is accessible to people learning how to code. You know, it's like something that's accessible in places like hackathons or just kind of like in the hands of people who can build cool things with it. In an ideal world, I'd really love a community around this. I feel like that's what really got me into just like tinkering with things in VR, in the XR space. And I'd love to see a community around it.
Yeah. And I guess that's what you're working on. Is there, I guess for, you know, I'm guessing you're constrained by the amount of units you can make. Part of what you're working on is to get this into the hands of developers. And I'm guessing you're constrained somewhat on like producing the hardware itself. So is there kind of any plans to host a hackathon so that you can have like developers come and try these things and like maybe come up with interesting use cases that you haven't thought of?
Yeah, we've had internal hackathons before. I would really like to get this in this. I personally have a soft spot for the student hackathon circuit.
Sure.
At the moment, it's been a lot of giving this to individual people so far.
Got it. Okay.
One day in the future, I'd love to have people working together and coming together.
Yeah. And if you do announce something, I'm sure we'll let our community know. Yeah.
Yeah.
I love that.
Where do you see, you know, XR, you know, in 10 or 15 or 20 years? So maybe we can go a little bit away from the roadmap of, you know, the technology you work on. I mean, even if you will be super successful, you might have competitors in 20 years, hopefully, because usually there are 2-3 companies coming up. So where do you see, like, in general, brain-computer interfaces, human-machine interaction, and the XR space merging? When do you see technologies like what you're doing will be available, you know, to a broader mass user base, like 5, 10, 20, 30 years?
Yeah, so I guess like the first thing I want to try and answer is a few different buckets of places where I imagine these two would come together. So the first is, I guess, like clinical applications. I think that's a huge one that often comes up when we talk about our technology. There's so many, I think, like XR applications that involve clinical applications, but imagine being able to merge that with CTRL-kit. Imagine you could control your computers and robots using your intention, so you don't have to like kind of contort your body to a controller. And you know, it's like, think prosthetics, think we've had people talk about like surgery applications, a bunch of like different cool things there. And there are a lot of like really great ideas from people in the XR space. And I feel like a lot of that could be enhanced with a more intuitive input device. The other,
but it's not very bold. I mean, you're not necessarily saying that, you know, everyone will wear those devices and interact with spatial computing only by, you know, muscle activity. Why are you so careful?
Sorry?
I think she was talking about like the immediate. She wasn't going down your path of 30 years.
Okay.
Now.
Yes. Sorry.
She's talking about now.
I'm just talking about like the future. I'm going to like extrapolate from there.
Yes.
Yeah.
Perfect. Then consider it as a lead.
Yeah. Cool. So, clinical applications, robotics, you know, like prosthetics. We talked about this earlier. There's a lot of like cool, I think, like, you know, like the XR space involves a lot of like virtual things. Robotics space involves a lot of physical things. Putting the two together and being able to control both in an intuitive way. Lots of cool things there. Productivity apps, also another big one. And I think my personal favorite is games. At the moment, a lot of like games are designed around specific controllers in mind, right? And the way you have to hold the controller, you have to contort your hand into a specific shape. And, you know, it's like the distance between different buttons and like the speed at which, like the number of buttons within a certain proximity and like the speed at which you can toggle between things or like trigger more than one thing at the same time. It's limited by a controller, and that's not really like in control of the game developer or like in the control of the like independent game developer. So imagine a world where you could have a game controller or a controller, I guess, where you can kind of map whatever action, whatever control schemes to your game. I feel like that's really impactful. I feel like at that point, it's like it kind of empowers game developers to create applications that don't force their users to play the controller. They can really play the game for real. And I feel like that would be really, really cool.
I think especially from an accessibility perspective, that does make sense, where I think also Microsoft has been kind of pushing on that end, where they built this very different Xbox controller that's like basically for people that cannot use the main controller. There's many different ways of kind of customizing it. So I think thinking on accessibility is like a really great way forward. We're starting to like VR AR also needs to make a lot of steps in that way. And some of the bigger the developers that have, I think, the time and also the mindset to work on it, like the people that come to mind is Alchemy Labs, where they've really spent the time to like think about all the edge case users of their game, whether it's short people, whether it's tall people, whether it's people that have very small space to play in and big. I know they've talked about accessibility a lot, even at GDC. So I think that would be really interesting. But to be honest, like the thing that strokes my imagination more is like, how does CTRL-kit work in a like on top of a controller or on top of like the already existing user interfaces as maybe like a modifier, or like having this another dimension of input that, because like I think it's hard to really stray away from like controllers because of how well they have worked so far. I mean, yes, obviously there's a lot of users that cannot use. I mean, there's okay, I'd say the majority of people that play games do use them in a pretty good way, and you get good at it. But like, and VR also has been trying to deal with this problem, right? How not to overcomplicate it. But I can imagine how these things can be used as modifiers and really like add another dimension to it. Has there been any kind of interesting things you've seen in that regard, where on the video game side of things?
Yeah, so I think three things come to mind. It kind of talks about this kind of like alludes to the third interesting use case that I've seen that we've built. So some limitations of current I guess like game/XR inputs. One, it doesn't I guess like for a lot of computer vision based things, it's hindered by occlusion. So, it's like optimal lighting settings, all that kind of stuff. That's really important. To a lot of controllers you have to take with you, and it's like a certain shape, right? Hang on, back to the first point about computer vision things. It won't be able to detect certain types of motion. So imagine things like snaps, which are really fast, or things with like complicated like finger configurations would be really difficult. So computer vision is a big thing that we think about. The form factor of controllers, another big thing that we think about. And I think the third thing that we think about is the kind of like hidden intention that's really difficult to get from controllers today. So one application that we've been able to create is, so you guys know Star Wars, right? You know how, like there's like the Force, and you're able to kind of like, like hold your hand out and control things using the Force, pick things up, move things around, speed things around, all that kind of stuff. So that's an application that you wouldn't be able to do with, like your Xbox controller. It's something that you wouldn't be able to do with, like your Vive controller. You cannot do that with your HoloLens or Magic Leap. And you cannot do that with your Leap Motion, because me holding my hand out like this looks exactly the same as me holding my hand out like this, but with a certain amount of force. You can do that with CTRL-kit, right? So that's like one such application we've created, and it just feels really magical. It feels, it's like, because we joke within the company that we have the most boring demo videos, because it's like, it's a video of like people like not really moving, but things are happening.
Right.
So, I feel like that's
often
like
the case when you build something intuitive and it looks like it works really well.
Yeah.
It looks really boring because it's working so well.
So I think the last one is the one that I'm really excited about. It's like on top. So let's say we have, like your Xbox controller, your Magic Leap or whatever, or your Vive controller, your Oculus controllers. You're able to use that. But now you have an extra dimension of, like let's say like continuous control that you wouldn't be able to get with those other devices. So for example, like me holding my arm out like this, I can control like up, down, left, right, and all 360 degrees in between. I'm also able to, let's say like fire something. I'm not sure if you've seen our asteroid video, but basically someone was able to like steer like the little spaceship in the asteroid game and shoot
right.
lasers, I guess, and also put up the shield. And they're able to do that with just their hand on the table. So all these additional degrees of control, I think there's just like a lot to work with there that we could use to augment current input.
Yeah, let's quickly talk about that actually. So the Asteroid video, so the Asteroid is a 2D game for, whatever. Listeners, you probably know what this looks like. It's you're a ship on a flat screen and you can rotate. You can either rotate clockwise or counterclockwise, and then you can push your thrusters so you can fly forward, and then you also have a shoot button and a shield button. So that's the kind of the modalities, or that's the dimensions that you can control. You can rotate, and you can choose to rotate in either direction with the control kit. So it's not just like one form. Okay, so I guess also let's go back to like what a developer, like you as a developer, what does it look like when you get the control kit and the SDK? Like what sort of outputs is it giving you so that you can use as input for your application? Like what does that look like?
Yeah. So at the moment we're at our kind of like alpha testing, like a set number of like selected users phase. So what we give out to our developers right now is just a subset of the things that we're working on internally. But some things that are available to our users are things like, like your hand bone position, it's like where all your joints are. So that's something that's available to you. And on top of that, you can kind of do that obviously behind your back, which, like something, you can do in your pocket, which is an extra affordance. So there's that. There are things that's like full on kind of motion. That's a full skeleton of your hand and fingers and kind of their position, basically. Yeah. Okay. On top of that, we also have a bunch of poses that we recognize, right? And people are able, and like not only to pose, like let's say like a fist, but also like the magnitude of tension / force that you're applying in that moment. Other features are things like buttons. So imagine things like taps, or imagine things like, like tapping your keyboard, but you don't need a keyboard. You can do it anywhere in any kind of context. That is. So
that's the combination of like the skeleton position of your finger and the force of that finger that that the intent that you're pushing to your finger, right? Like that's the combination of understanding how much force you're trying to give to your finger and also where your finger is.
So it's, I think of it a little bit differently than that. Okay. I think of it as more of you're intending to tap, and whether you actually tap or whether you are just pushing that intention forward gets detected by the neurons that are firing through your arm, and that's kind of what we work out.
Okay, got it. So it's
So those are some features that we release out to developers today that are available to people. Obviously just like a subset of the set of things that we're working on. So, like stuff like that typing thing, that's still something that's a work in progress. And we do a lot of thinking internally about the best way to expose that to people, such that this is useful and intuitive, for developers. What we have right now is a SDK for Unity. So again, it's like for XR developers, for game developers, this is something that you can essentially plug and play. Given this to a bunch of people, and I feel like the time it takes for someone to open a box and look at CTRLkit for the first time, and them being able to do stuff in Unity, or being able to run the software is like somewhere in the order of like 10-15 minutes. Being able to build their first Unity application with it, somewhere in the order of like another 10-15 minutes. So like within 30 minutes, you can go from opening your box, creating your first Unity experience with CTRLkit, which I think is just like makes it like really intuitive and easy to plug and play for developers.
Yeah, that's on par with most developer kits. Like it took me close to like 2 hours to get my first Magic Leap build.
Oh running.
Yeah. Which maybe it's different now, but every time I want to get something going with Magic Leap, it's like a lot of time.
You got to download.
I wanted to ask, sorry, Peter, but does that also include like the training that do you have to do training when you get a control kit, or how does that kind of work?
When you say training, are you referring to like people knowing how to do these gestures, or?
I guess do you have to train it to yourself at all?
Yeah. So a lot of what we release today are generalized models. So I could give it to you today and you don't have to teach it how you pinch or how you move your fingers or whatever. It just kind of, it knows, or it looks at past patterns and it knows what you're doing.
Got it.
Or tries to remember what you're doing.
That sounds like that's not simple at all. And that's probably one of the bigger things that you guys are working on,
Definitely,
right? Like, yeah. Okay. That's because like there's like you talked about how much variability there is between people, and so okay, that's
all these
pretty
people with PhDs to work on this problem.
So
Peter,
we talked.
Were you going to say something?
Yeah, I'm kind of having a meta question here. So
yeah,
let's say your technology is super amazing and detects everything that my arm is doing, whether I'm really moving it or I have those intentions. Isn't there also, of course, a certain problem with the world being, something that neither VR or AR technology in general doesn't understand it? Because I remember back then I ordered my Mio, however it's called, and I was trying to do a presentation. And it worked really well while I was switching the slides. I mean, it still was not detecting the neuron activity or the axon activity, but more the muscles. But then you'd start to, stand next to your colleague who also gives the presentation, and you kind of start to write with your hand. And that started also to switch the slides. And in a sense, there is kind of a gap between, let's say, on this meta level, between what your arm is doing and what it's supposed to do in the real world. Is it something that is a big obstacle for it to be used for augmented reality? Because there you have less concrete understanding what the environment is doing, whether in VR you kind of control everything. And is that why VR fits, at least for now, way more?
I think there are two things that come to mind when you prompt that question. One is state machines. So, it's like, are we in a state where we are, like whatever, like trying to switch slides or trying to do a certain thing in an XR space? The next thing that comes to mind is the fact that, I don't know, like me triggering a button without holding anything looks a certain way. Me holding this glass of water while triggering a neuron looks a different way. So we've had demos where it's like one of my colleagues here, it's like is able to control that Dyno runner game. When it's like Chrome doesn't work for you, you're not connected to the internet, and you can kind of like, press the space button for that.
We're in Germany. We know very well on internet.
Yeah. So yeah, being able to control that, it's like not only pressing a button, but also with his hands in his pocket, but also being able to like hold this mug and have it like trigger and not trigger, making sure that there's kind of like false positives and false negatives don't trigger or like do trigger. It's kind of like something that we think about as well. So I love that you're kind of like on the same path there.
Yeah, that's interesting, because I guess when I'd seen a video, I think it was that Dyno runner game, but it was like a person, it was like a single input kind of like control, right? Like jump or don't jump. And I was like, okay, that's not that impressive. But I guess thinking in context to like different hand positions and like the different things you could be holding or where it could be, I guess the hard part really is to filter that signal from the noise. Does that also work more with like the other dimensions, like to actually have like this magnitude of like how much, let's say it's not just like a single jump, but like how far you're jumping or like which direction in a 3D environment? Like, does that also work with like different hand positions, or am I thinking about this correctly also?
Yeah, so I'm just thinking of how I as a developer would implement something like that. For the Asteroid game, let's say I wanted to play Asteroid, but then I wanted to get up, go do something else, come back. I kind of think of that in the state machine state of kind of like side of the world. So I don't know, I can imagine, it's like I'm playing Asteroid, I'm not moving my hand. My hand's like flat on the table. And I can imagine a world where I fire a neuron, a very like predictable and reliable button to signal like, hey, like I am going to do something else, like turning it on and off. I can imagine that's one way to approach the problem.
Right. But I guess the question I was thinking more about is like,
position.
Yeah, like your hand, like you can be holding different things, right? It's like a mug, or you're like scratching your head, but you still want to be controlling the thing you're doing. So like the hard part is to really understand that you're doing something else that's unrelated, but also the signal from your brain to the game, right, is being picked up. That's kind of like what you're.
So do I understand you correctly, Azad? You imagine you doing like the household, moving around stuff, doing the dishes, in between, like in microseconds, just typing a message that you see popping out on your Magic Leap 4.
Yeah. I guess, yeah, that's definitely one application of it, but that sounds super complicated, and I don't want that to be I mean, is that possible? And yeah.
Yeah. So I think there's a lot of work to do there, but we have done the Dyno runner game with someone holding a mug as well. And it's able to get that as well. And it's able to differentiate, like, like whether you are holding something, whether you're not holding something. So I can imagine a world where, it's like bring all these like little components, obviously like a lot of work to do there, but bring all these components together. And, it's like, I think one thing that I'd be really excited about are kind of like smart home devices, being able to control that as you're like whatever brushing your teeth.
Yeah, look at your light and then like turn a virtual knob to turn it on, or like, yeah, I guess force pull, force push is like such a cool, it's like such a thing that we already think about. And like as a kid, I kept just every like few months just checking in and making sure that I can't force pull something. Like, I don't know if anyone else
I did that as well. Yeah.
I did that as well.
Like, let's just make sure I didn't develop that skill.
Yeah.
Yeah. Can you combine your technology with, let's say, eye tracking from Toby from the Wi-Fi Pro, or maybe some other measurements? Is there any benefit?
I don't see why we couldn't do that.
Has that been done?
I have not personally worked on that.
Got it. Okay.
So I asked this question because when you think about a few previous questions, it was kind of about how can you figure out intention from what you're doing just from your arm. And of course, when you would, let's say, wear a mobile EEG system or a dry EEG system and figure out, when you have certain intentions, you could combine it with the arm movement, because the EEG itself doesn't give you a really big bandwidth of data unless you go for Neuralink, which we should also briefly mention that Ellen is trying to make us having USB-C in the brain. But when you could, get a little bit information from the brain, a little bit of really good stable information from the arm, maybe gaze, maybe overall with some kind of Kinect technology, the body position, maybe even heart rate and some other things, could you build like the ultimate state machine of the human, like complete cognitive modeling that would allow the XR to completely adapt to you, behave like a teacher, and tell you magical stories that you'll totally understand? Or
oh my God, Peter, you're just all.
If you want to build that, I'd be happy to get you a kit.
We'll talk afterwards.
Peter, I love your optimism, and you just take things to the nth degree. Always.
Yeah, a man has to dream, right? Or we have to dream as humanity.
Yeah.
Okay, so I guess let's reel it back a little bit back to like reality, because I'd imagine some of the people that are listening here that would definitely be, or perhaps are already on the waiting list, or even have it. Like, what's? I'm sure there's a lot of ideas that are floating in people's heads, but like, what is really like possible? Like, I'm sure part of like your job is to like help understand, or help people understand like the constraints of what can be done and what can't at the state that we're in today. And this is a podcast with a lot of developers, and like we're pretty realistic when it comes to like how things work, and I think we're totally okay with that.
For sure.
We don't have to like promise the world. But yeah, kind of like how would you want people to approach their first kind of like, would you call, by the way, is this a BCI? Like, would you call this a brain computer interface? Yeah. Okay. You do.
Or neural interface, I guess.
Neural interface. Maybe not full on BCI, because that I guess implies there's something on your head.
That's a philosophical question, whether your external system, your nervous system is part of your brain.
I'm gonna skirt right around that discussion of naming and nomenclature, because that's like my least favorite thing to talk about. But yeah, kind of how would you like people to really like approach this from a realistic perspective? Like what?
Yeah. So let's see. When I give someone a device today, I try to communicate to them what's possible and what's not possible, given the kind of features that we're trying to get feedback from today, which, is like just a subset of all the things we're working on. What we really try to do is, what we're working towards is creating the ultimate neural interface, something kind of like a class of problems that we're not as focused on is, say, 6DoF tracking. So I think a lot of people, I try to give this a lot to people who are Unity developers, just like going back to my roots. A big question that comes up is, it's like, oh, how can I use this for VR? And I think one thing that I want to try and communicate right off the bat is that like we don't provide positional tracking. So if I had this and I walked to another room, it doesn't know that I walked all the way over there. And like I feel like,
sorry to interrupt, but like the position of the hand or the position of the fingers in relation to each other and the wrist, but it's not about like, oh, my wrist is over here or over here, but it's just about like it's a 3DoF kind of finger tracking to
exactly, yeah.
So you could combine that technically with like a Vive tracker, and have that, right?
Exactly, yeah. So I think that's something that I try to communicate right off the bat. It's like we try to tackle a set of problems. We don't try to tackle everything. We are hoping that, like the Vive tracker is like a really great solution around this. Another thing I've tried out is like magically hand tracker. So like it knows where you are as long as your hand is in front of the device or the HMD, right? Being able to combine those two things and leveraging the strengths of like those two devices. Things that we are, the point of our us giving this device to developers is to get feedback for it. So sometimes developers are like, hey, I keep trying to use this certain control scheme, and I noticed that it's not as comfortable. So I think getting feedback on, it's like, I guess like we release things to the world and we want to get this in the hands of people, right? And we want people's opinions on this. So I don't know, thinking of like control schemes, at the moment we, it's like we're able to detect different, I guess like finger pinches with different levels of, I guess like accuracy, right? And we made the assumption that like finger pinches are something that developers would want that would be useful to people. As it turns out, most people get the most bandwidth out of using their thumb, their index finger, and their middle finger, and then their kind of like ring and pinky finger are kind of like just there, and not a lot of people develop like control schemes around this. So I think like I guess like one really interesting control scheme that that someone brought up was the idea of like a D-pad. But imagine you're index pinching and middle pinching for left or right, and then you rotate your hand, and this is up down, index pinch and middle pinch. So being able to like do something like that and like I don't know, play Tetris or play Pac-Man or whatever like really really quickly. We found a lot of people working with certain types of features and not other features. So I think this kind of feedback helps shape our product, right? Knowing what the kind of things that people want to build. So we're kind of like exploring a lot of things, moving a lot of different directions. And I'm not saying that like everything is always like what like the perfect or like right decision, but we like that's something that we try to like communicate as well.
Yeah. And obviously like even, you have an idea like, okay, we need to have pinching for every finger. And then you realize that like 99% of the time you're actually not using like a pinky pinch.
Yeah.
Helps
it's also not comfortable to do that for long periods of time. So,
well, that's exactly it. Like that's how people won't really use it.
And
you're like, okay, maybe we don't really need to concentrate on really perfecting those gestures, and we can concentrate on the first two. So that's super valuable feedback. And I think I'm glad you talked about like hand tracking and 6DoF tracking, and that's not really that's not the focus of what and in fact, that's been done, or there's ways of doing that, very cheap ways of doing that could work with your system.
Right.
And I think that's a sort of like, I think information that's really crucial for developers to have to set their expectations in the right way so that they know what, they can think in the right way, right? Like, and think along the right paths.
For sure.
So I guess before we end things,
Neuralink.
Yeah, let's let's talk about Neuralink.
Sure.
What has been the talk around your office about Neuralink? And
do you have an API ready?
Sorry?
Do you have an API ready to connect to it directly?
Oh my gosh.
I'm just kidding.
But yeah, how kind of, to be quite honest, like I've looked at it from a very peripheral perspective. I know very little about it, but like how have, the people you've been working with and your company kind of like been thinking about, reacted to it?
So I think we have two kind of like very different approaches to how we're trying to solve the problem of like brain-computer interfaces, right? What Neuralink does is invasive. What CTRL-labs does focuses, or like we're very specific, like non-invasive. We're also focusing, so like, it's like you don't have to go to surgery for this. You don't have to put something on your head for this, because I don't know. I personally don't really want to go out in the world with like stuff on my head. I would prefer to like have something like under my sleeve and my arm.
Sure.
So I think what they work on.
Corrode. Your device not in the body, and the body doesn't try to fight it, right?
I guess not. But what they're doing is really, really cool. And we feel like it would be really beneficial for the people who are interested in getting surgery. I'm not as psyched about getting surgery. I'm personally really scared of like needles. And like knives and, like going under the knife. So, but we feel like what they're working on is really cool and would be really impactful for the people who are interested in doing that.
Yeah. Yeah. I mean, obviously I won't be the alpha tester, but maybe beta or delta or whatever. But they're like just also the other thing that they're working on that I haven't heard you guys talk about is more of the haptic or the taptic feedback. In fact, it's not even haptic for them. It's like a neural simulation, stimulation and a simulation of what that haptic, that touch or that thing would feel like, rather than actually having actuators in your like fingertips. So that was really interesting to me. That was like both the control and intent, but also the feedback. So
although they didn't show anything that proves that they can do it later.
Yeah. I mean, this is all coming from, Elon Musk, which
the crazy part is the technology that they show really looks promising and kind of realistic. I mean, some stuff DARPA apparently developed, like the sewing motor or the sewing machine, and all in all, everything that they have there, maybe except the wireless transmission, was somehow done, just not combined. But yeah, of course, Alan talking about connecting to AI and brain in the vet, which is a very old metaphor. It's kind of, you saw the client is cringe a little here and there.
Yeah, I mean, but I typically don't know how to I try not to be conclusive about these things and try to approach it from like an objective perspective and just look at what is there. But that's cool. I'm glad to hear. It sounds like you guys are all interested and excited about it, and even giddy about kind of like other people working in this area, so that you don't have to, even the initial marketing pitch of like, hey, there's other ways of controlling things, and because of these technologies becoming more accessible, there's now different ways of doing things. So you don't have to like do the whole pitch every time. You can have like a comparison.
And on top of that, it's like the more people there are in this field, the more I think talent it brings to this field and the more visibility. So, it's like win-win for everyone involved, right?
And iterating on the good and bad ideas, and the better ones kind of like becoming better. Yeah. It's definitely a rising tide lifts all boats, or whatever that that thing is. Cool. Jesslyn, how can people find out more about CTRL-labs and CTRL-kit, and also how can people reach you if they have questions?
So I think the best way to keep up with what we do is to follow our Twitter account at CTRL-labs.co, and we have a website, control-labs.com. And I think the best way to reach me is on Twitter. I'm J Tannady. That's JTANNADY.
J Tannady, love it.
Yep.
Okay, and you can find us on Twitter at ResearchVRcast, and we typically also retweet a lot of like new news and developments from our previous guests and people. Just things that happen that are past the episode. We like to have our followers like see the developments there, and you can find us also on Discord. We have an active Discord kind of like episode discussion community, and also guest suggestions and new science stuff that gets announced. We have links and discussions in there, so find us there. And Jesslyn, that's awesome. A quick question before you end: is there any sort of like developer forum for people that have received the CTRL-kit to like collaborate or to share code? Or
yeah, we do have a developer forum. It's currently closed to people who do have a device.
Yeah. I figured. Okay, cool. So hopefully, good luck to people that apply and are on the waiting list. Let us know if you receive something, and
please fix typing in XR.
Trying our best.
Yeah, great. Thank you, Jesslyn, for joining us.
Oh, thank you for having me.
All right, and thank you all for listening. Goodbye.